All right. Well, let's go ahead and get. Oh, I'm muted. All right. Let's go ahead and get started. I would like to get a poll first. I'm not going to do a real poll, but just put in the chat or say out loud. Um, I would like to get an idea as to how much, and this is not a judgment thing. Just this is a curiosity thing. How much have you had a chance to read the project? Or I don't know what happened in class on Thursday, so I don't know if y'all have talked about it at all in class. I need to get an idea as to how much you feel like you already understand about it. So if y'all could tell me that, that would be really helpful. And I need everybody to tell me, so everybody has to answer. So either out loud or in the chat.
So me personally, I just saw your I just got back from class, so I haven't read the whole project. I only read like the first 2 pages, to be
Okay.
honest. Then I saw the email,
Okay.
and it
All
was
right.
already like 2:55 at the point. So then I just hopped on Zoom. That's me
You
personally.
know, no, that's fine. I didn't tell y'all to read it or anything like that. Yeah, I just wanted to. Yeah, that's what I needed to know. So it's not a problem if you hadn't. I just needed to kind of get an idea. Okay. Okay. And has he talked about it at all in class? Or y'all have not seen him since he sent it out? Is that right?
Yeah, he sent it
Um,
out on Saturday, I think, so we haven't
Okay.
talked to him much about it.
Okay. All right. So what I would like to do, and I really need y'all to do this, and not just not do it because it's fine if you don't understand it, but I need everybody to have an idea. It's like the words I'm going to be talking about, the things I'm going to say. We're going to break for 15 minutes, and during that 15 minutes, what I want you to do is, if you have not already read it at all, take a look at it. If you have read it, look at it a little in more detail. As much as you can get out of it during this 15 minutes is great. And if you still don't understand anything, that's fine. But it's just going to be helpful for me to not be talking. I don't want to be saying words that you have no idea what I'm talking about. And so at least if you know, oh yeah, that was, wherever it was on the page. So I don't know who it was who just came in, but for the next 15 minutes, I'm just going to pause. I'm going to turn off the camera. Um, and I want y'all to spend that 15 minutes looking over the project to kind of get as much of an idea about it as you can, and then we'll go through it in more detail. So 15 minutes, so y'all do that, okay? And I really need you to do it. Don't just spend 15 minutes, taking a break or whatever. Got it? Yeah. Thumbs up? Yes. Okay, so I am back. I hope everybody is here. We didn't lose people. Let's see. Nope, everybody's here. Okay. And I think I am not muted. And yeah, all right. Okay, so you have the project description. Now you've at least looked at it. If it's the first time looking at it, probably there's a lot in there that doesn't make any sense. So we're gonna talk about it together, and you should ask questions. And you should also make corrections. If I say something and you say, "Well, wait, that's not how I read it," let's talk about it and make sure that we're all kind of on the same page, that we all understand. So if you, I think that you might have gotten an email. If not, it's right here on the Moodle page, the project description. There is also on the Moodle page, if you look, and this is important as well, the project grading template and demonstration instructions, because there's something on here that you want to make sure that you know, that this says that you will demonstrate your code on Tuesday, November 28th. So that's the Tuesday after Thanksgiving in lab. And also on that same Tuesday, you have to turn in your code, including your Verilog code, your constraints, and your test bench. You have to turn all of that in on Tuesday. Your report is not due until Thursday, but you have to have everything working and running and ready to turn in on Tuesday. So I wanted to make sure that everybody saw that, because it's not on. It doesn't say that on the on the project description, but it is here. Okay, so not sure how I wanted to start this. All right, so I'm just gonna talk about stuff, and you just need to stop me when it doesn't make sense, and I will try to explain it in another sort of way. So the first thing that we have is he starts in the handout describing just a scheduler. So we have a scheduler, and in this particular example, the scheduler takes as an input one of three things. So it can either take as an input, say 0, 0, which means idle, which means there's no task to be done. Or it can take 0, 1, which means a task of type 1. Or it can take 1, 0, and this would be a task of type 2. So these are inputs into the scheduler, and we're going to see later on, we're going to say they're inputs into the allocator. And he has these as variables T for type. So let's see. Yeah, so just called T. And so T, in this case, T would be 2 bits, because you only have a total of 2 types of different tasks. So these are tasks that have to be done, and so you only need 2 bits to describe that. Now, in the project that you have to do, you're given a description of what you have to do. So you have your required project, and then you have some bonus additions. And I will be honest, I don't see, I've seen people try to do the bonus editions, but like I put in my email, a lot of times it was at the expense of actually getting the project done. So what you don't want to focus on these bonus editions yet. Right now you want to focus on the required project, and if you get that all done, then you can look at the bonus editions. And in the required project, you are only required to have, let's see, I wrote this down. You are only required to have 2 types of tasks. So 2 types of tasks. And so until I get to the point that I have done the project and everybody else has done the project, I'm going to assume that everybody is working towards the required project. And if you do the required project, you can get 100%. So it's not like you're missing something by not doing the bonus editions. So that's just what I'm focusing on, is 2 types of tasks. And since that's the case, we're going to still say that it's 2 bits to describe the task. I'm not even going to talk about what the options are. So we're just going to say there's 2 types of tasks. And then the tasks take different amounts of time. And as an example, and this is not what your project does, this is the example in at the beginning of the handout, and then we'll talk about what your project requirement is. In the beginning of the handout, it says that type 1 takes 1 clock cycle, and he uses system clock for this. I'm going to call it button clock. And the reason I'm going to call it button clock is you have that little panel of debounced button switches, and every time you press one of those, that advances the clock to tell your finite state machine to go to whatever the next state is. That is going to be different from the clock that is on the board, so the basis clock. And you're going to use the basis clock to make a divided clock. You might. This you might not do, because for the required project you only have to use 1 LED display. If you use more than 1 LED display, you would need the clock div. But you might use the basis clock for your LED display, like we did in one of the labs where we had to make the divided clock to go to show the different LEDs. You might not actually need this one. And I'm not sure on that, but I'm going to call the clock that advances from state to state, I'm going to call it the button clock, because that's going to be what you get from pressing the button. So type 1 takes 1 clock cycle, and type 2 takes 2 clock cycles. At any point where something is not making sense or you have a question, please holler out. I'll try to keep an eye on the chat, but I'm not really good at it, but do holler out. So you can say that you have the different states you can be in. So you can be in the idle state. So the idle state is that you don't have no task needs to be done. Or you can be in the state of you're doing a type 1 task. Now a type 1 task in this example only takes 1 clock cycle, and so if you're in this state, then that means at the next state you would be ready to take a new task if you needed to. You can also be in a type 2 clock cycle 1, because remember a type 2 task takes 2 clock cycles. And so you can go from idle to a type 2, or you could go from type 1 to type 2, because once you've finished your type 1, you can start a new type. But if you're in type 2, the first clock cycle, the only thing you can do from there is to go from type 2 to clock cycle 2, because the type 2 task takes 2 clock cycles. And so this and then from here, if you are in the type 2 state, you could go from here, you could go back to type 2 clock cycle 1, you could go to a type 1 task, or you could go back to idle. So those are all your different possibilities of where you could go. From type 1, you can also go back to idle. From idle, you could go back to idle. But notice from a type 2 clock cycle 1, the only place you can go is to a type 2 clock cycle 2, no matter what the input is. And so another thing that he has you do is he has your machine output whether or not it is able to take a new input. And he has this as variable R. And so if you are in the idle state, then let's see, does he do 1 or 0? In this first example, he has it as F, but later on it's R, and R. Okay, so R equals 0 means busy. And R equals 1 means can take new task. So if you are in the idle state, you would have R equal to 1. If you're in the type 1 state, you would have R equal to 1, because if you're in that state, that means the next state you're free. If you're in the type 2 clock cycle 2 state, you would have R equal to 1. But if you're in the type 2 clock cycle 1 state, you would have R equal to 0, because you would not be able to take a new task. Okay, so this is the first thing he describes, is this idea of the scheduler. And I'm going to skip to what your required types are before we talk about the allocator. So, but let me, I'm not, it's not exactly true. Okay, I am going to talk about, let me pull it up. Okay, so at the beginning of the handout, he talks about that scheduler that I just did, and I pulled up the wrong thing. This is more a schematic of what your actual project is supposed to do. So these things that are called stations, these are what handle the tasks. So those handle the tasks. And they receive from the allocator what type of task it is that they're supposed to do. And they give to the allocator the R variable, which tells whether or not they are ready to accept a task. And in your project, it says that you are required to have 2 stations. So we're just gonna get rid of this one. Get rid of all my annotations. So we're just gonna ignore this one. We're gonna make that one go away because we're, as my dad used to say, when people would, along the lines of, as soon as someone else lowers their standards, I will lower mine accordingly. But we're gonna stick with the minimum, and then if we finish the minimum, then we can add things to it from there. So the station is going to be the one that reports whether or not it is ready to take a new task or not. So the station does that, and the allocator decides what tasks go to what station. So then this is how he describes the types of tasks that you will have. How do I get rid of that? Okay, so here is what your project has to have. You will have you have to have 2 stations, and they will be station 0 and station 1, but they don't work the same. One of them is faster than the other on one task, and the other one is faster than the first one on the other kind of task. So what this is saying is station 0 takes 1 clock cycle for type 1 task and 2 clock cycles for a type 2 task, and station 1 takes 3 clock cycles for a type 1 task and 2 clock cycles or 1 clock cycle for a type 2 task. So let's look at what a state diagram for each of these is going to be. So this is for your actual project. So this is station 0. You'll have station 0 is going to have these different states. You'll have idle, and you'll have type 1, and you'll have type 2 clock cycle. And now it may seem like I'm doing this in a weird order, but you'll see why. Clock cycle 3, and then type 2, clock cycle 2, and type 2, clock cycle 1. So the reason I put it in this order is that from all of these states, they are really kind of identical, because whether you're idle, or if you are in type 1, or if you're in the last clock cycle of type 2, then, oh wait, do I have that backward? Oh shoot, I'm reading the chart backwards. Type 2 takes 2, not 3. This is, I was reading my chart backwards. So this is station 0. So let's change, just take this one. So this is type 2 clock cycle 2 and type 2 clock cycle 1. So those first 3 are really kind of all of the same, because from each one of them, at the next state, they are ready to take a new task. So for all of these, that when they're in that state, they can report an R equal to 1. Did we say 1 meant that it was ready and 0 was it was busy? Yes. Okay, so all of those would report that that R equaled 1. And only clock cycle 1 needed to report that R equals 0. So for station 0, you really only need to have 2 states. And your 2 state, I think I haven't done it yet, so I'm not 100%, but I think you only need 2 states. And the 2 states are, you're ready to receive a new task. No, I am incorrect. Let's not do that. Let's make these all separate states, because we have to also keep track of how many tasks we have completed. So that's going to be something different. Okay, so forget that. They're not all the same. They are definitely different. So they will actually report, I think they'll report a couple different things. So this idle would report R equals 1. And did it complete a task? Let's give that a new variable name. Let's call that completed. It did not complete a task. Type 1, R equals 1, but it did complete a task. Type 2, clock cycle, I'll put these back in order now. I'll make that clock cycle 1 and this clock cycle 2. Type 2, clock cycle 1, that would be R equals 0, because it did not complete it. It's not ready. It has to go to the next clock cycle, and it also has not completed a task. So it would have R equals 0 and complete equals 0. Now, type 2 clock cycle 2, it does have R equal 1. It is ready, and it did complete a task. So that would be complete equals 1. So it looks like if you wanted to, you could combine the type 1 and the type 2 clock cycle 2 states if you wanted to. I think at this point I'm just going to keep them all separate so that I know what's going on. Okay, so I'm going to pause for a minute and see if people have questions on what I'm talking about right now. Okay, I'm going to assume that we're good. All right, so now let's go on and let's talk about station 1. So station 1 So station 1 would have idle, type 1, step 1, type 1, step 2, type 1, step 3, and type 2. So if it's idle, then R equals 1, it's ready, and complete equals 0, it has not done a task. Type 1, step 1, R equals 0, it's not ready because it has to go to type 1, step 2, and complete equals 0. Type 1, step 2 also has R equals 0 and complete equals 0, and it has to go to step 3. Now type 1, step 3, that one is ready and it has completed a task, so you would have those. And type 2 only takes 1 clock cycle, so it would have R equals 1 and complete equals 1. You also I don't know yet because I haven't done it. I haven't figured out the logic of how you're going to tell it, which state to go to. But you like that. Whether or not it takes, so if it is finished a task, if it's in state idle or type 1 step 3 or type 2, then it is ready to take a new task, and whether it takes a new task, that'll say what state it goes to, and that is going to be an input from the allocator, and that's going to be a separate module. But if it's in type 1 step 1 or type 1 step 2, it doesn't have a choice of where to go. That's not going to come from the allocator. That's just going to be, it has to go to the next stage. And when we get to a session where we talk about the Verilog, we'll get to that. Okay, so that is the stations and what they do. But let's now talk about the allocator. Okay, so the allocator is going to take an input. These are going to be switches, and the switches are going to tell it that on this clock cycle it is being asked to tell these stations to do some tasks. And the project says that you have to allow it to accept 2 tasks simultaneously. So let's talk about what that means. So if you're accepting 2 tasks simultaneously, then the way I would do it is I would make T a 4-bit number, so from 0 to 3, and T0, T1 would be 1 task, and T2 and T3 would represent another task. And these are going to be switches on the board. So you will assign, and the switches you're going to use are I would go ahead and with everything else I've been saying, assume you're not doing the bonus, but I would use this layout right here for assigning the switches, because you can always not use. So if we're only using 2, like if let me highlight, let me grab this. You have also in in Moodle, you have this page that you're going to fill out that you should have with you when you go to lab, that's going to tell you how you assigned your switches and your LEDs. So this can be handy to keep that like with you so that you know which ones you've done as which. I also put the like the V16 and the V17 on there so I know what I've got. But what I would do, this will allow for the most flexibility, is I would make, we're just doing 2 tasks, so I would do, and our tasks only have to be 2 bits wide, so I would make these switches, so T0, T1, T2, T3. That's how I would do it. And then you just wouldn't use these switches unless you get around to doing the bonus. But if you get around to doing the bonus, then you don't have to like redo all the constraints. So that's what I would do. And so then these switches would tell you that on the next clock cycle, you're asking the allocator, let's say that I put in a 0, 1 here and a 1, 0 here. You're asking the allocator to say you want a type 1 and a type 2 task to be done if possible. So that's what these switches would be. So you're saying these are the tasks that you want to be done. So the allocator takes the T values and also looks at R input. Now you're going to want R to be a vectored signal too, or you could just call it R0 for station 0 and R1 for station 1. So you could have 2 separate variables for that. So the allocator will look at those and decide if it can assign the tasks. So if it has, let's say we used R0 and R1. So R0 is station 0 is ready, and R1 is station 1 is ready. So if R0 equals 1 and R1 equals 1, whatever tasks it gets, it can assign them. Now, if R0 equaled 0 and R1 equaled 1, that would be fine as long as one of the tasks it received was 0, 0, because 0, 0 means don't do anything. So that would be fine. But if one of the stations was not available and it was asked to do 2 tasks, then it is supposed to indicate with an LED Could I go back to station 0? I can, if I know what. Can you tell me what you mean by that? Just the types in station 0. Yes. Okay, so station 0 has both stations can take both types. So that both stations, so the types are coming from the switches. And the switches do not tell you what station that it goes to. So the switches will tell you what types you've got. So you'll have 4 switches, and those switches should either be 0, 0, 0, 1, or 1, 0, because you have 2 possible types. This one would be type 1, and this one would be type 2, and this one is idle. And the switches do not tell you which station they go to. They go to the allocator, who then decides whether or not to send them to a station and what station to send them to. So you have 2 stations. You have station 0 and you have station 1. And either one of them can take both types. Station 0 can take type 1 and type 2, and station 1 can take type 1 and type 2. It just so happens that they spend a different amount of time doing them. Station 0 is type 1. Okay, so station 0 takes 1 clock cycle. That's clock cycle. Takes 1 clock cycle for type 1 and 2 clock cycles for type 2. Station 1 takes 3 clock cycles for type 1 and 1 clock cycle for type 2. So, but either station can take either type. So what happens is when you press the button on the button clock, so you'll press the button, press that button, and then at that point you read your values of t. So you've got your 4 values of t, t0, t1, t2, and t3. And the allocator module, so you'll have a module for the allocator, so probably call it allocator, and I would call it allocator RR. Will take these signals, and it'll also look at the R0 and R1 that are coming out of these. So R0 and R1, that's saying whether or not they're ready. And if it can assign both tasks, then that's great. If it can't, because it got 2 tasks to receive, it received 2 tasks and they're both busy, then it's supposed to output to an LED I believe that's the F output. Let's see. Yes, okay. So the allocator will have an output called F that indicates whether or not the scheduler was able to assign all the tasks on the current clock cycle. It doesn't say whether the light means you could or you couldn't, but you'll need to know which way you decide to do it. And so the allocator is going to do have several outputs. So the allocator receives T and receives the R's, and then it outputs an A. Now A, I'm probably gonna do A as a vectored signal. I don't know how I'm gonna do it. For right now, I'm just gonna say I'll have an A0 and an A1, and an F. And so it's going to look at what it's being asked to do. So let's say it's asked to do a type 1 task and a type 2 task. And it's going to look at whether R0 and R1 are ready. Let's say that R0 is ready and R1 is not. And then it's going to decide. And there's no rule for how to decide. You can choose your logic of how to allocate this. It can only allocate one of these tasks because R1 is busy. So R1 can't get anything. So it can allocate one of these two tasks to A0. So let's just say it picks that one. It makes that A0, and this goes to station 0. It was not able to allocate all of the tasks, so I'm going to make that light the light. So I would make that be F equals 1, and this is going to be an LED light. On the other hand, let's say that both of my stations were ready. Then the allocator is going to send one task to station 0. It'll send the other task to station 1. And in this case, F would be 0. So the way I'm envisioning it, and I don't know if this is how I'm going to do it or not, is that I'm going to make a module that I'm going to call station. And in that station, I'm going to be able to set it up so that it could process the different types with different amounts of times. And then in my top module, I'm going to instantiate 2 different copies of this station based on the parameters. So the way I'm thinking about it is I would have my station RR would have some variables like time, I'll call it time for task. No, I'm going to do this the not official. I'm not going to do that. I believe I'm going to have separate modules for the different stations. So I'm going to have a station 0 module, and I'm going to have a station 1 module because the states are so different. So the logic on the states and what the next state is going to be is so different based on the amount of time. So I'm not going to try to be efficient and try to make one station module that could handle the different times. I think that would be too hard. So I'll have that. And I'll have module allocator. And you're going to have other things as well. So another thing that has to happen that's not shown in the schematic is you have, well, it kind of is shown, but it's not shown how you get there. So, it does show from stations. So here's the display unit. So the display unit, that's going to have the 7-segment display. And the 7-segment display is supposed to show how many tasks you have completed. So if you remember, I had each station also output whether or not they completed a task. So I might have yet another module that has, so I might have a module that is my task counter. And so this would take as input from the stations whether or not they completed a task. And then if they did, it would increment a counter. And then it would display a value on the 7-segment display. Now, I'll talk more about this when we actually get to the code, but he said you can use one display, which is a lot easier than using multiple displays, because if you use multiple displays, you have to deal with like making them flash really quickly, and that's what the divided clock is for. But you can use a single display and display in hexadecimal, and so you need to be able to display the digits 1, 2, that's not a 3. Wait, that is a 3. What? Yeah, 4, and so forth. And then when you get to 10, rather than doing 10, you would do A. And for B, the way you display B is you do a lowercase b, because if you did an uppercase B, it would look like an 8. So that's B. C. I guess you do a lowercase d so it's not confused with a 0. A, B, C, D, E, and F. 10, 11, 12, 13, 14, 15, and G looks like 6, doesn't it? So I guess you do a lowercase g. Yeah, so that would be a lowercase g as opposed to a 9, which looks like that. So you're going to use your 7-segment display to display the numbers from 0 to 15. So 0 to 15, but only 10 through 15 will be in hexadecimal. And that way you only have to use one display instead of using multiple displays. It says you can use multiple displays, but do that as a bonus, and I suggest that you wait and get everything else working before you start working on that part. You also have to have 2 modes, and you'll control what mode you're in with a switch, and one is reset mode, and all reset mode does is it sets everything back to 0. So nobody's processing any tasks, no tasks have been processed, everything goes to 0. Let's see, everything goes to idle. There's no task input, all tasks are ignored, everything goes to idle. And it says you can do this synchronous. Everything gets reset with the system clock, so you can wait until you press the button. So you have all these switches, and one of them is going to be for the mode. And you can wait, and when you press the button, it can check that mode, and if it's in reset mode, then you can reset. Or you can have it asynchronous to where it's always checking that switch, and as soon as you flip that switch, it goes to reset. And there's no either way you want to do it is fine. There's not a requirement on that. There are 2 other possible modes, but those are bonus. And okay, so let's review the basic requirements for the project. Okay, so these are the basic requirements. You accept 2 types of tasks. So those are the switches. Those are the T values. And so you'll have switches, and you'll say, I'm sending you a type 1 task and a type 2 task, or 2 type 1 tasks, or 2 idles, but it can accept 2 types of tasks, type 1 and type 2, or idle. And you can so 2 types of tasks, type 1 and type 2, and also 2 tasks. So it'll get 2 of them at once. You'll have 2 stations, station 0 and station 1. Both stations can accept both types of tasks. Each station processes the tasks a little differently, and that's described here. And as I just said a minute ago, when I do my code, at least the first time through, I'm just going to do them as separate modules. I'll have a module for station 0 and a module for station 1. You have to be able to display a flag that says whether or not you were able to schedule the tasks on the clock cycle. You have to display on the 7-segment display how many tasks have been assigned since the last reset. So every time you press the button, it should receive new input and do the tasks if it can, update the task total, and do that. If you get to 16 tasks, it'll go back to 0. And in reset, everything goes back to 0. And I think I've gone over that.
To input the task,
Yes.
do we need a load to be able to like update?
Yeah,
Or is it always updating?
No, I know you definitely need a load because that's what the button clock is for. So that's so well okay. Okay, so no. Let me think for a minute. So you will have your code. So you'll have a case statement. And no, this would be case state. Okay, so this is what I'm thinking. I'm thinking that you'll have your allocator that will read the t-values and then decide what a values to make. So like say it would say a equals a0 equals 0, 1. And then in my module station 0, I'll have an always block, and in my always block I'll have in my sensitivity list, one of the things in my sensitivity list is going to be A0. So whenever A0 changes, that tells me, okay, I need to update my state. And then I will have a case statement, and in my case statement, my case would say, well, let me change my state based on whatever state I'm in. So, and this, I would have, these would be the list of the states that I'm in, and this would, what it does is going to depend on what value A0 is. So like if A00 equals 1, then the next state equals T1. I'll go to task T1. And then, so I'm not going to do a separate load. I'm just going to base what my next state is on the stuff that I get input here. If I'm in state T2, 1, I'm not going to have any if statement. I'm just going to have, I'm definitely going to be that the next state is T2, because, or T22, for example. So your question on the load, okay, so where you would have a load, that would be on one of the, you could. So if you wanted to build in the possibility of loading so that you're in a particular state, you could do that, but that's actually one of the bonus things. That is debug mode. So that's an extra mode that you could add in. You do not have to have it in your basic design.
Okay, thank you.
You're welcome. I'm sorry that was a long answer, but I kind of had to think through it to come up with. And again, this is just my first thinking on how I'm going to approach it when and if I have time to sit down and do it. I can't guarantee that I actually will. I'm going to try, because if I do it, then I'll be better able to help y'all. But I can't, but I'm going to try. All right, other questions? Oh, I was going to show y'all that there was one more thing I hadn't gotten to. Although it looks like my computer is locking up. My computer does not want to do this project. So you will have to give it the constraints. And so what I would recommend is that you use, so the difference between this, the bottom layout here and the top layout, is that the bottom layout is set if you wanted to do the debug mode. I would go ahead and use the bottom layout, except have where it says debug, these are going to be your switches that say whether you're in normal mode or reset mode. That's what these are. So normal mode or reset mode. You're not going to use these two switches. So you're not going to use the station switches. And you're just going to use the first two of task 1 and the first two of task 2. So if you are absolutely certain that you are not going to do any of the bonus, then you can have just reset and T okay, I'm not able to write. And then the next 4 switches could be T0, T1, T2, and T3, and those would be your inputs. So if you're absolutely certain you're not doing any bonus, then you only need these 2 switches and 2 more switches here. Let me make sure that's right. I mean 4 more switches. Yep, that's right. So the minimum display that you need, so the minimum number of constraints. And you can, I think you can do it however you want. I don't think you have to do it the way that he has here. Let me see. You have that layout page. I don't think it really matters. I don't think it really matters, but you could have the first two switches are for normal and reset, and then the next two switches, T3 and T2, is for the type of task 1, or the type of a task, and then T1 and T0 are the type of a task. And then you have to have an LED that shows whether or not you had a fault. So let's see, so you'll have one LED that shows the mode, I think. Yes, so 2 LEDs for the mode. So you'll have 2 LEDs for the mode that'll show whether you're in normal or reset. Then you'll have an LED for your flag to say whether or not you were able to assign all of the tasks. And do you have to say what the tasks are? Yeah, okay, so F needs to be at the other side, so F would need to be here. And then these LEDs tell you they're going to light up. These correspond exactly to these switches. And then you also have the 7 segment display. So I think that's the minimum number of constraints you have to have. Okay, other questions? Can I get any input at all about, can I get any input at all about how, not whether you think you can do it or not, but whether you think you understand what it is you're supposed to do?
I pretty much understand what we need to do. It's just figuring out how to do it later on.
Right.
Yeah.
You have a better understanding. Okay. The problem is setting them up. Sure. Yeah. So I will have more sessions where I will well, I mean, and you can get ideas from talking to each other. You can't share code. You can't write it and say, here's what I did and give that to someone. But you can certainly share ideas. You can say, well, how did you do this? You say, oh, well, I set up a module to do that. And that, that is encouraged because, you learn a lot by, sharing with that. So that's good. So we will have more sessions where I'll share what I've done and y'all can share what you've done. And certainly there will be some people who come up with better ideas than I have. And we'll see where we go. Now, there's not really that much time, right? We have this week, and then we have school for 2 days next week, 2.5 days, and then Thanksgiving, and then you come back and it's due. Will this be posted to look back? Yeah, I'm going to post it as soon as it's ready. Yeah. And I do plan on having like more videos later. Last semester, I was really discouraged because one of the videos I made a video like of me demonstrating my completed board, like this is how it's supposed to work, and I said, I begged people, I said, please watch it, make sure you're doing the right thing, and nobody watched it. I think it got like a total of 4 views out of however many people took the class. And sure enough, a lot of people didn't really know what it was they were supposed to be doing. So I'm just gonna say, if I beg y'all to watch a video, please do, just make me feel good. Let's see. Okay, any other questions? I mean, don't you think if I right now said, oh, hey, we can watch a video of a completed project, I mean, I'd want to see it. I don't know. I mean, I would think, but I think the problem is that people who haven't really read it too carefully or haven't thought about it think that it's easier than it is, maybe? I don't know. It's so weird doing Zoom. If we were in a regular class, y'all would be talking back to me and I wouldn't be talking to myself. But, okay, but we will have that on Wednesday. And did I understand, are y'all not going to have any more homework for the class?
No. He said no.
Okay, but you will have new information that you'll have to know for the final, and so I need to be able to work in helping y'all with the project and getting ready, just review problems, okay, and getting ready for the final, because whatever new material there is will be on the final. When will the lab be open for testing? I don't know. I'm not involved with that at all. However, I do have a basis board in my office, and you are welcome to contact me and set up a time to come to my office and use my basis board, at a time that's mutually convenient for both of us. But I don't know about the lab. I don't think that's been posted yet. I don't know. Has anyone looked? I think there's a place in Moodle where it was going to be posted. Let's see.